So let me start right away, and I'm sure all of you know about everything about HLB and the impact, especially the impact in Florida. I mean, which is we lost more than 70 or even more percent of the production. So I will skip all this introduction and then go right away to some of the technologies that we are developing to mitigate, if possible, the disease. So, as you know, HLB, the bacteria, lives in the phloem. So there's some effort in Florida right now from a lot of growers to use track injection, which I assume that most of you are familiar with. It's not a new method. It's a pretty old method. And the idea is that we to inject the different type of materials, antibiotics, for example, directly to the inside the tree through the phloem or the xylem, it will move up and potentially kill some of the HLB bacteria. So again, it's not a new method. As you can see here, you need to create a hole. As you can see these pictures, I think you can see my arrow. And then with something like a syringe or pressurized system, slowly inject some of the materials directly inside the tree trunk. So the problem is like this process is very labor intensive, as you can see in these two videos, and very time consuming. Again, they go with a drill, they create a hole, which is first might be a problem, and then they put there some like a pressurized system that they can leave it there for hours, or at least 20 to 30 minutes, so for the tree to slowly absorb the material. Again, very time consuming, very expensive and labor intensive, and my damage also the tree. So a lot of growers also try to use the system from both sides of the tree so they can have a better uniformity, which is we found that if you inject from one side, maybe half of the tree will get the material. Like if, for example, if you inject with dye or any kind of color, we see that the color goes to the leaves, but only from one side. So it's better to inject from both sides. But again, very, very expensive, very time consuming. So as an engineer, what we try to do is to to automate this process. And then this is two initial prototypes that you see here. So the idea is that we inject through hollow needles. So as you can see in both of them, we punch the tree from both sides, and through the needles, we apply with higher pressure that the tree is able to absorb. And then we can, first of all, automate the process, but also minimize the time required for the tree to absorb the material. And usually we apply now with 100 ml of OTC, but it can be any type of antibiotic if it's approved. I will skip this part, but we had several problems with these two prototypes, so we developed something different now. Still, we need to improve that. But as you can see, you can put it at the back of any farm vehicle. It's more like a positioning arm, a robotic arm that has the end effector at the end. Here is a video that you can see the needles that we punch the tree. So we create smaller holes, and I will give you an example of that. If you see these three graphs, the X time is the X axis is the time. And if you follow in the right one, you see the volume going up. And you see here the volume drop. So we can apply, we're able to apply 100 ml. In this case, is water, I think. But with OTC, we have a similar response in less than 30 seconds. So it's very, very quickly. So we can reduce the time significantly of the application. So here we keep going just to see what will happen. The first figure presents the flow rate. The second is the pressure, sorry. And as you see that when we are getting a plateau at the volume, so the tree cannot absorb more, the pressure is building up. So probably it's good to stop the application before that. But at that point, we're able to apply more than 200 ml. And then you see that the flow stops. So we did a lot of trials. We had a grant from USDA and my colleagues explore or investigate other aspects of this application. For example, when is a good time to apply, what is a good season, time during the day, how many applications per year, when is a good time, how many days before harvest. But again, I will talk more about the engineering part. I'm an agricultural engineer. So what we did here, without just looking all these details, we apply a specific material, OTC, 100, 5,500 ppm, 11,000 ppm, and water. But the important part here is that for the automated system, which is this ATIS, automatic track injection system, it took around 18, less than 20 seconds average time to apply 100 ml of the material. And the manual, it took more than 20 minutes. This actually is in minutes, this is in seconds. So more than 20 minutes. And sometimes it actually, you need to leave it for hours because the pressure is low and it takes much more time for the tree to absorb the material. So we reduce the time significantly with this system. About the damage, wooding, this is the manual. As you can see, the first picture, you see a bigger hole because it's a drill based. And the second one, it's much smaller. It's through the automated system, and it's smaller because we don't really drill, but we punch the tree. So we create a much smaller hole. And we are investigating right now the effect. So we expect to see less damage from the automated system. And also what we try to do now, we try to fully automate the system. So how we do that, we include an AI-based sensing system. So we have a camera, depth camera that we use in order to fully, again, automate the robotic arm. So the system can detect the tree trunk, the diameter, the injection points, and then fully control the robotic arm. We are still working on that. This is just a video of the track detection, but still it's under development. We haven't yet finished that, but there's also some conference papers that you can find more information about this system. So now in a different technology, AgroView is the name of this technology. The goal is to analyze, process, analyze, and visualize data from drones, airplanes, satellites, even for ground-based platforms. So the main goal here is to collect data at the tree level. So, and we developed the system for a lot of reasons. In Florida, we also have hurricanes, so even to evaluate the damage after the hurricane, we need to have a tool like a rapid tool to evaluate the damage. That's why we start developing AgroView. So as you can see here, this is how it looks like when you log in. This is a 2,000 acres of citrus blocks. So when you click any of these blocks, you see some initial analytics. So you see the number of trees. We can also detect the gaps. You see that as a pie. And I assume you can hear me, right? I don't know if you lost connection.
You're back.
So do you want me to go back?
Yes, please. Yes, we missed a few slides from you.
Okay, sorry. What was the last one?
This one. Next one.
Okay, so did you see this video?
So yes, we saw.
Okay. So again, this is the conversion between with the automated system, we can reduce the time, the application time to 18 seconds compared to 24, 25 minutes or hours. This is the hole from the drill-based system, the manual system, which is much bigger than the automated system. So we expect to have less damage, and we are still investigating that. Here we try to fully automate the system, so adding a AI-based sensing to detect the trunk diameter, the injection points, and fully control the robotic arm. So we can reduce labor. And this is just some initial testing of this sensing system just to detect the tree trunk and measure the diameter. And then also we can detect the injection points, which is not that simple because you see not all the tree trunks are vertical. Some of them, they are not that clear also to see. In a different technology, AgroView, again, process analyzes and visualizes data from drones, satellite images, and airplanes, or from ground sensors too. It can be used as a rapid response tool to extreme weather events like hurricanes that we have here in Florida. And the goal again is to detect every tree and collect information, about every plant. So again, this is a around 2,000 acres citrus field. When you click any of the blocks, you see initial analytics here. We have already commercialized that through a company, spin-off company named Agriculture Intelligence or AgIntel. So if you click agroview.ai or agintel.ai, you can find more information about this technology. You can use it even right now. You can upload raw images from the drones, for example, and we have a stitching engine. And after that, you create the perimeter of the field, and then the models run right away. Or you can even upload the orthomosaic map. And then also we analyze, we estimate the leaf nutrient concentration. And this is the average numbers from NPK, but also different micronutrients. And when you click or double click the field or click view block, this is a little bit older version, but it looks something like that. You are inside the field with all these dots. The green ones, you see there are tree detections. The blue ones are the gaps. And you see that we have a lot of gaps. In this case, the grower wanted to order new trees to replant. And he didn't know how many trees to order. So he had to send people in the field manually to count all the gaps. Was again, very expensive, very time consuming. So he came to us and we worked together. In less than a week, we had all the maps ready. He knew exactly how many trees to order. And plus he had this information for the entire fields. So here height is selected. We see also different height categories. You can now change that, I think, from 2 to 9 bins. And you see in this example, trees less than 7 feet tall, 7 to 12, and 12 and plus and more. And this is a video demo. Again, this is a little bit older version. You can also find this video in our Twitter account. The red color here represents the gaps. See how many gaps we had in this case, like almost 50-50. And this is because of HLB. Again, here you are inside the field. Different colors represent different height categories. You can select and select the trees. You can zoom in, zoom out. Again, colors are different height categories in this example. We run a lot of algorithms in that. It's very important also to understand the orientation of the field. It's not just a simple AI. The blue dots are, again, all the gaps. In this case, we have a lot of gaps. Plus here, you can have, if you have multiple flights, we can also compare data between the flights. So we can have a 4D analysis. The fourth is like the time. Again, it's very interactive. You can play with how many categories you want to present, from 2 to 9 again. And you can even select to present trees that are more than 10 feet tall, for example. And also we developed these fertility maps this is zone-based management. So what you see here, nitrogen is selected, and we have, in this case, 4 different zones. The red is the deficient, and then we go low, green is optimal, and high, the blue. And down here, you see the range of these values for nitrogen. What deficient means, for example, is 0 from 2.2%. And then you can generate a report, and the report looks like the right part of the picture, where we also give some recommendations. You see the average values in every zone, but also we develop an application map So you can select the rate that you want to apply in a different zone, and then we are developing the precision and variable rate fertilizers, spreaders, or sprayers for foliar applications. And then you can manually select how much you want to apply to every zone, and the sprayer is able to understand where the tractor is and spray based on the rate you apply here. And this is, we connect that with real-time sensing through another technology. We call it AgroSense. And there are patents for all these technologies, actually, AgroView and the AgroSense. So example here with a sprayer, broadcast sprayer. It's a very common sprayer that we use in Florida. We have a number of nozzles, multiple nozzles, so we can actually now control all individual nozzles or zones. Let's say that this is zone 1, and then you have zone 2 or zone 3 and 4. So zones of nozzles or individual nozzles. And why we need to do that? First of all, we have all these gaps. So it makes no sense to spray in areas that you don't have trees. Plus, in Florida, again, we don't have uniform fields. We have a huge variability in the tree size. We can have a big tree next to a small tree or a medium-sized tree, and then you have a gap. So you need a system that can detect that variability. And based on that, change the amount we spray. And how we can change that? We can change them based on the number of nozzles we trigger. And also we try to connect that with a zone-based management that I showed you before. But also you can control the speed of the fan and based on the leaf density. And this is what we try to do. Again, we can have zone-based management. Let's say zone 1 in the left side has 3 nozzles and zone 2 other 3, and go on, or it can be individual nozzle control. This is again a little bit older version of the AgroSense. We use a low-cost LiDAR and 2 cameras, left and right. And in real time, we process the data and we run AI models to detect the height of the tree, the leaf density, and I will give you some examples. And based on that, change the rate that we apply. And also we count fruit. And this is the graphical user interface. A few things to point out here is like this is the spray buffer. So the user can change that. This is how many inches or centimeters you want to spray before the tree canopy and after. And you can even change that. This is something that the growers ask for. In order to be sure that you cover the entire canopy, you need to spray maybe a few centimeters, inches before the detection. And also here, another thing that applied to all trees that you see in this part is you can change that. You can decide you can apply in only mature trees, or you can apply only to young trees. So this is something else that growers also ask. And there's also some other functions that we don't need to go over now. So in this video, let me pause it for a minute. Let me pause it somewhere here. So the sensing system is somewhere in the middle here. And then you see the right camera in the right part on this video. So what we measure, we know the location through a GPS. We also count fruit, not all the fruit, but this is very important also for yield prediction purposes. But we count the fruit that we can see, and then the tree condition, which is healthy, at risk. I'll give you an example of at risk. When we mean healthy, all of them are HLB infected, but we call them healthy. At risk, dead. We can also detect dead trees and gaps. And then the height. Based on the height, we can control the number of nozzles or zones that we trigger. So what you see in this video, first of all, you see the fruit detection in real time. And then here it's a gap. The tree that you see here is from the other row. So you see the right side stop spraying. This is at risk because we have less leaves. So we can even evaluate the canopy area. And based on that, you can even change the spin of the fan, for example, so you have a better uniformity. By doing all these things, you can even save more than 30% of the chemicals. Depends again the variability that you have in your field. This is two other videos. So you see in the left side here, there's a gap. It will stop spraying. And in the, now I'm actually in the left side, here is a dead tree. It didn't even spray in this one. So you can even recognize a dead tree. The second video, what you see, there are smaller trees. First of all, in the turn, it doesn't spray because there's no trees. Then it's more like on-off because they're smaller. And of course, not all nozzles are triggered, but also it's on-off to save some chemicals. And you see the pole here, it detected the pole, but it didn't spray. So there are other commercial technologies available that there are more object detection. They detect objects, and then if there's an object based on the height of the object, they spray. In our case, we analyze the data in real time, which is very important, this the real-time analysis, because we store only information, not data. Again, this is very important for post-processing. But also you can recognize that here, for example, this is not a tree, so no need to spray. And I think this is my last slide here. We can also produce maps at the end of every application. So the first is a spray heat map, and the second is a fruit heat map. So this is through AgroView. So you can take the data through a USB stick and upload it to AgroView, and AgroView has a function to develop a feature to develop these maps. And every red dot here is a GPS location. When you click any of them, you see all this information here: time, date, speed, flow, accumulated flow, and fruits. So it started from this point, it netted somewhere here, which is, this one again was almost a 500-gallon sprayer. So what we do here in Florida is, like, at this point, the operator needs to stop, put a flag, drive all around down to the this point at the beginning of the road, put another flag, and then drive back, refill. And then when he comes back, he needs to identify these flags in order to continue spray from the same point. But sometimes that doesn't happen, and they don't spray for this in this small area, but that might be very important and significant if you spray for pest diseases. So this is also a very good tool to evaluate the quality of the job. And again, different colors here, they represent different rates. If you zoom in, you can find also more differences. And this is a fruit heat map. Again, we don't detect all the fruits, but still you can get some good indication, good idea about what to expect. And then based on that, you can develop, we develop pretty accurate yield prediction maps. And as you see, some areas we have less fruit because there were younger trees. And again, thank you so much. That's my last slide. Thank you for the invitation to talk with you. I can